both wheels, and they have a fan on them, and so they're both getting the same force blown on them, so to speak, the same motor force for the same period of time, and one weighs half as much as the other one, and it obviously goes twice as fast, the one that weighs half as much. He also does the same experiment with a 4 mass, so a mass 4 times as heavy, and it goes much, much slower, demonstrating 1/4 of the velocity. So it's just a pretty good piece of evidence, okay, that people really can't be arguing that the same force can't create twice the velocity in the half mass object, that there's not some sort of inertia. So there's no inertia on that yellow car that's stopping it from going twice the speed. There's no 1.4. Same force, it's going twice as fast when the same fan is blowing the same amount and pushing the same hardness for the same amount of time and all that crap. It's just a pretty clear piece of evidence.
Yes, that's right. It's a pretty clear piece of evidence that proves conventional science right. This is no evidence against kinetic energy as you falsely claim. So first of all, why didn't you share the webpage, or why didn't you even show it? Because there is some crucial information there that unveils why you are wrong as always. For those who are interested, this is the link to the webpage. Unfortunately, YouTube absolutely refuses to let me share the link. No matter how I try it, my comment always vanishes. What we see in this experiment is that indeed the carts are experiencing the same force in the same amount of time. And that's the important thing here. The same amount of force can be applied in the same amount of time. This is totally different than releasing both carts with the same amount of energy input. We have done many experiments where we released a 1 and 2 mass with the same energy input, and the result was that the same force was not applied in the same amount of time. Whereas in this experiment, the same force was in fact applied in the same amount of time. The whole difference is how long the cart is allowed to accelerate. Ask yourself the question, how long is each cart being pushed? So we have two cases. Case 1 is the case where both carts are accelerated in the same amount of time. What happens? The fan pushes both carts, the fan runs for the same amount of time. Both carts are accelerating for exactly the same duration. What you see, the light cart speeds up quickly, the heavy cart speeds up slowly, but you stop both at the same moment. Result, the light cart ends up going twice as fast. Why? Acceleration means how quickly speed increases. Light cart, speed increases fast. Heavy cart, speed increases slow. If both speed up for the same time, the one speeding up faster ends up much faster. Same acceleration time plus stronger response equals much higher speed. Case 2, different acceleration times, spring/rubber band. What happens? Both carts start accelerating, but the push comes from stored energy. Once that energy is used up, acceleration automatically stops. What you see? The light cart accelerates very strongly, but it stops accelerating sooner. The heavy cart accelerates more gently, but it accelerates for longer. Result: the light cart is faster, but not twice as fast. It ends up only about 1.4 times faster. Why? The light cart burns through the available push very quickly. It accelerates harder, but runs out of push sooner, so the extra speed gain is limited. Stronger acceleration times shorter time approximately equals modest speed increase. Conclusion: the experiment with the fans on the carts perfectly validates the predictions of conventional science. Goofy Woofy will now keep using this experiment to falsely back up his momentum is energy fantasy.